Hey folks, this is Charles Max Wood, and I just launched my book, The Max Coder's Guide to Finding Your Dream Developer Job. It's up on Amazon. We self-published it. I would love your support. If you want to go check it out, you can find it there. The Max Coder's Guide to Finding Your Dream Developer Job. Have a good one. Max out. Hey everybody, and welcome to another episode of the Ruby Rogues podcast. This week on our panel, we have Dan Shapir.
Hey, all the way from Tel Aviv.
I'm Charles Max Wood from devchat.tv. We have a special guest this week, and that is Josh Ponelat.
It's Josh Ponelat. Hi, from South Africa. These countries are cool.
That's really cool. I've talked to a few people from South Africa over the years doing the show. Dan's in Israel, and I'm in the United States, so we're totally multinational here.
Yeah. By the way, where in South Africa?
So most people know two places in South Africa. It's either Johannesburg or Cape Town. I'm in neither. It's a very small town along the coast. Kind of sleepy, kind of touristy. It's called Plettenberg Bay. You should check it out. It's really beautiful.
Great. So after this, you'll go to the beach, maybe go fishing.
I think a good Mai Tai and a beer or something like that, because why not, right? Live in paradise. You gotta live in paradise.
All right, I'm done talking about it. It's not going to get above freezing here today, so... This episode is sponsored by Sentry.io. Recently, I came across a great tool for tracking and monitoring problems in my apps. Then I asked them if they wanted to sponsor the show and allow me to share my experience with you. Sentry provides a terrific interface for keeping track of what's going on with my app. It also tracks releases so I can tell if what I deployed makes things better or worse. They give you full stack traces and as much information as possible about the situation when the error occurred to help you track down the errors. Plus, one thing I love, you can customize the context provided by Sentry. So, if you're looking for specific information about the request, you can provide it. It automatically scrubs passwords and secure information, and you can customize the scrubbing as well. Finally, it has a user feedback system built in that you can use to get information from your users. Oh, and I also love that they support open source to the point where they actually open sourced Sentry if you want to self-host it. Use the code DEVCHAT at Sentry.io to get 2 months free on Sentry's small plan. That's code DEVCHAT at Sentry.io. We brought you on to talk about Swagger and OpenAPI. Do you want to just kind of give us the quick elevator pitch as far as what Swagger is, OpenAPI is, and kind of how they tie together, and then we can dive in a little deeper on the discussion?
Yeah, sure. And that's actually a big question because Swagger and OpenAPI are used so interchangeably that a lot of people struggle with it, and it's silly. It's silly because it was sort of, the disambiguation didn't launch easily. So it started as Swagger. Everything was Swagger. And Swagger is a specification or a set of protocols around describing RESTful APIs. That's the buzzword, right? RESTful APIs. And then when Swagger got bigger and larger, it got taken over by a company called SmartBear. And when SmartBear took over, they wanted to keep the heart of it as open source and as open as possible. So they donated the specification, the thing that describes it, into the Open Linux Foundation, and that's called OpenAPI. So going forward, OpenAPI is the spec, and Swagger is just the tooling that SmartBear kept. Hopefully that sort of gets us going there, and we can touch on it again, figure that disambiguation out.
Yeah, it's interesting. I kind of went and dug through the Swagger website and the OpenAPI website, and I'm still not sure if I'm completely clear on what they do. Do you want to just talk a little bit about how Swagger and OpenAPI work to solve some of these issues?
Yeah. So this is front end, right? So we know what package.json is, right? It's this JSON file where we throw in our dependencies and we've got a field called name. In order to make package.json work, we need to know what fields can go in there. OpenAPI is the specification for these files, and it basically says which fields can go in there. And the purpose of this file is to describe an API. So if you have, say, Twitter's API and you want to know how to send a tweet, you got to know its method, say post. You got to know its URL, say, /tweets. I probably shouldn't have picked Twitter's API. It's not my go-to. But in order to capture those details, you need to have a way of capturing those details. I mean, sure, you could just write it down in a napkin, but OpenAPI is a standard way of describing those details. It's typically a YAML file. So if I were to give you an OpenAPI definition, I'd be giving you a YAML file. And from that, because it's done to spec, you get all the benefits. You can create documentation, or you can get tooling to understand an API, what's in it, and what the data going in and coming out looks like.
So basically, you're saying that it's essentially a standard schema for RESTful APIs?
That's it. Yeah. So that's OpenAPI. That's the big buzzword because OpenAPI is the one that's the heart of it. It's the schema.
Dan said RESTful APIs, and I'm wondering, does it encompass any other sorts of API schemas or approaches? GraphQL kind of does it differently enough to where I don't know if the specification makes sense for that.
So no, OpenAPI does not describe other types of APIs, and where I'd say type would be something like gRPC, GraphQL, or any other RPC frameworks. The focus is on HTTP. So now we say RESTful, but RESTful is also a design constraint. It's bigger than HTTP specifically. So OpenAPI would probably be best described as an HTTP schema, describing the HTTP details like method, URL, parameters, and the body.
That makes sense. I'm also wondering with OpenAPIs, so yes, you make a post request to this URL. Does it also include the authentication schema?
So yeah, it does include those details. In authentication, they typically get carried over either as a header, so you could describe it just as the header itself, but OpenAPI does have a special cases, so special ways of describing authentication and authorization. And you can give them a single name, and they can go as detailed as being, say, OAuth 2, HTTP basic, especially in the latest specification.
I gotcha. So yeah, you can say it's a JWT, or it's from OAuth, or it's an
Right.
API key in a header, or a token from one of these in a header, or anything like that. You can put that in there.
So you could describe it, just using headers or just using query parameters, right? Which typically the two that I'd be in. But there is a special case because it is so standardized and you want to have the nuances of it. Just write it in one place. Say, this is OAuth 2. I'm not going to say this is just an authorization header, right? Because you want to know those details, and that's important to communicate.
Yeah, it's an authorization header, but you got the token for it from OAuth 2.
Gotcha. Exactly.
All right. So the other thing is on the parameters, are they typed, or are there recommendations for the specific format? Because I may say like start date, end date, but here in the US, we do month, day, year, and in other parts of the world is day, month, year. So I may want to specify even the format, right?
So OpenAPI does its best, and I'll describe how it does that in a little bit of high-level view, but it's going to have its limitations of how far it can describe the details of the request response, because it does describe both, right? They're both important. In your case, it would be something like this is a string, and it has a format of date time. Right? It wouldn't go so far. So datetime would be against one of the ISO standards. It wouldn't easily be able to describe, say, an American format date string, but you could use something like a regex or something like that to sort of put limits on the string that you're sending.
So to clarify this point, suppose I'm describing, I'm building an API and I want to use the OpenAPI. Does it generally mean that I just apply existing schemas to my API, or does it mean that I need to extend the schema to cover my API? What would be the typical way that I would go about it?
Okay, so let me try and break that out there. OpenAPI gives you the spec of how to describe APIs. You would start with either a tool or your IDE, because now you want to write or generate a YAML file that describes your API. And you would start with the basics like URL and method. When it comes to describing the pieces of it, say the query parameter, or more specifically the body parameter, the body parameter specifically uses something called JSON schema, or a derivative. It's sort of they kind of fudged it a bit there when it's not full JSON schema. They're changing this now, but it is very, very close to JSON schema. That would be the shape or type of data that you're sending back and forth. Beyond that, it would be, you could say that this is a JSON or this is an XML body type, or anything that fits that sort of standard by adding the MIME type. I mean, we can look into a quick run through of how you would get something working from OpenAPI. I find a lot of people find that useful. Should we give it a bash?
Yeah, sounds good to me.
Okay. Typically, people come to OpenAPI after they've got an API. They want to describe an old API. They want to get this API under management. And they'll do this. They want to first, they want to get it down on paper, if you will. And so they've got this API. They'll use tools like curl or Postman or a bunch of others to interact with this API. And then they're going to record that into a document that describes those interactions. Now, tooling is getting more and more advanced where this can become somewhat automated. As you interact with your API, you can take that and it'll generate an OpenAPI definition or a YAML file. Once you've got that, you can sort of clean it up and prepare it so that it will match the API that sits on a server somewhere. Once you've got this YAML file, which describes the details of some, possibly all, requests and responses that come out of your server, you can then generate documentation to say, okay, and well, now I can generate this documentation. Now I can see my API. I can also see what's in it at a glance. And then I can go beyond that. So once I've got my API described in some formal specification, which is what OpenAPI is, I can now, use tooling to really leverage that and take it to the next level of, putting this in my CI/CD pipeline to check if my API changes or to generate SDK clients. And once I've got that phase, which is typically the way people are introduced to OpenAPI and Swagger, I can start designing APIs before I build them. All right, so that's sort of the frontier. Let me describe it. Let me tell you what an API could look like, and then let's go and build it from that spec, right?
So if I would want to contrast OpenAPI with, let's say, GraphQL, GraphQL is usually used in kind of like a greenfield type project. I'm going to be building a new API. I want it codified. Maybe I'll use GraphQL. What you're describing is I already have an API in place, and I want to codify it. I want to document it. I want to kind of get it under control so that going forward, I won't make a mess of things and introduce all sorts of contradictions. So if I understand correctly, what you're saying is I can use this process and this method of describing, let's call them HTTP-based APIs or even RESTful APIs, and then I'll record what I have, I'll codify it, I'll document it, and I'll kind of set it down in stone, as it were, in a bunch of YAML files. And from that point on, I can ensure that I don't introduce contradictions, that I have proper testing, that if I want to develop a new client for this API, I'll be consistent with it. If I want to rewrite my server, I know that I'll be consistent with the APIs that I already have. And going forward, if I want to enhance the API, I can do it in a quote-unquote sort of a standard way. Am I more or less echoing what you said?
Yeah, I think so. Let's put GraphQL to the side there for a second. We can revisit it for sure. But what you've described is, the first stage or the first interaction is, let's get this API formalized, codified, if you will. But where it really gets exciting is when you start designing ahead of coding. And this format gives you this possibility of getting feedback on an API, which, as we found today, APIs can live a long time. And their commitments, especially with your public APIs that sit out there and say, this is our API, it cannot easily be changed. So we want to get it somewhat right ahead of time. And we've also got this medium of connecting front-end and back-end developers. So you can code your back-end independently of your front-end. Now you want to keep those feedback loops pretty tight either way, but you can code against a contract of an API, right? So the API, so now you can just code against that. And you can put mocking on either side of it. GraphQL it's definitely used in greenfielding projects, but it is an entirely different schema. It is a protocol as well as tooling and things like that. OpenAPI describes HTTP, right? It doesn't introduce anything new to HTTP. Whereas GraphQL, you go through one endpoint and you describe your data as a series of nodes on a graph, which is pretty cool. And then they've got a custom schema, or it is schema, right? It's a string that you send into a GraphQL server, and it will take that string, break it down into some AST, gather the data, and send it back to you, which is great for bandwidth-constrained clients, right? Because you're asking for a small set of data in a compact way, and you're getting just that data. HTTP has a bad rep for, well, we've got the RESTful semantics of A, B, and C. And so if I want to get all the data I need for my client, I have to make several requests, sometimes piggyback off older requests. So I get one request, and based on that, I'll make another request. And there's definitely ways of getting the benefits of GraphQL into HTTP, several interesting projects around that. But coming back to what OpenAPI is, it doesn't add anything new to HTTP. It is just a way of codifying it and allowing tooling to leverage that document, that YAML file, to be able to do all sorts of things.
So it's kind of like schema for schemas.
Yeah, that's definitely very meta, and I like it. And that's pretty accurate too, because OpenAPI describes how you can describe your API, but then you need to describe your API, right? So that's a schema for your API, a schema of schemas.
The thing that I'm seeing here is that if you put the schema up, and let's say you put the specification together in a YAML file, people can grab it, they can look at it. I'm assuming you put it in a YAML file so that a program can actually pick it up, right? And you can
100%.
use this to specify a driver for the API. Is where I see people using this. So, yeah, what does that use case look like?
I'm glad you brought that up, because when Swagger was smaller, it was an API schema for humans and computers, right? So YAML was chosen because it's somewhat easier to write than JSON, which is very strict, right? If you have a trailing comma on JSON, it blows up and you start wondering why that's the case, whereas YAML is far more forgiving. But of course, you want computers to be able to understand it, break it down. So yeah, it is a format to share. Once you get the YAML file, sure, you could read it, but it's much more convenient to get a tool to generate something pretty for you, right? So you get a nice little website or web page generated from the YAML on the fly, and that you'll end up consuming. Or you'll use the tooling to generate those SDKs or server stubs. Again, all of this circles around this one document that simply tells you how the API works. Maybe not the connecting points, the semantics of, call this operation and then this one. And then when you have all those done, you'll have done a bank transaction. It's more on the concrete inputs and outputs, right? Which goes a long way.
So I assume that these days a common use case for these YAML files would be to generate a DTS file or something like that.
I'm going to be ignorant here. What's a DTS file?
I was going to ask too.
DTS file is a definitions file for TypeScript. So it basically specifies an API that you can use from TypeScript, and then you will get all the autocomplete and stuff and good stuff like that in your development environment.
And that's a fantastic use case. And yes, that is one of the ways that OpenAPI helps, right? So you generate a client in TypeScript. Not only does it generate the TypeScript definitions, but you've also got the SDK itself, right? The code that'll execute. So in your IDE, you can explore an API by simply hitting tab, right? Which is fantastic. I mean, that for me is like nirvana almost, because now I can sit there and say, I want to execute this. Tab, these are the list of operations. What data do I need? Tab. These are the fields, and I can hit go.
Are there use cases other than the tooling then that we're seeing with this?
Yeah. So it all comes down to tools because you want computers to process it.
Yeah.
But in addition to documentation, which is probably the leading use case, you want to show developers how to use your API. And you get that almost for free, because once you got your YAML file, bam, you've got a website. And there's several great projects out there that'll do this for you. Then we've got our SDKs, our server stubs. But the other use case, if you will, is the oversight of knowing that your API is consistent in style is now becoming more and more popular. The fact that all your operation IDs have camel case, which a lot of larger corporations are big on, because that consistency gives them a strength to move developers around, that gives them the quality that they're looking for, that their API doesn't look completely different. There's the oversight that comes from knowing breaking changes. Adding a query parameter is fine. Taking one away or changing the shape of a JSON object might not be so great. And so if you've got the previous definition and you update to a new one, you can now tell in your CI/CD pipeline if this is now a breaking change. So all of these oversights come from knowing your API. And OpenAPI is that thing. You know it once you've got it written down. And I'm hoping that there's going to be a whole bunch of more things that we haven't thought of to add to this because, yeah, knowing the thing is having it described, I guess.
Given that we've spoken all this time about OpenAPI, what are we going to, bring up the topic of Swagger? Because we talked about how Swagger is distinct from OpenAPI. So, what is it and what does it mean?
Now's a great time to bring it up. So, again, looking back at the history, everything was Swagger up till a point, and then they took the specification part out and they donated that, and that became OpenAPI. What was left was all the tooling, the initial tooling that helped make Swagger useful. It wasn't good enough that, you can describe an API. You want to get that documentation and those client SDKs. So there's a whole bunch of tools with the word Swagger in them. And that's what Swagger is today. So when we refer to Swagger, we're referring to those tools, of which Swagger UI is probably one of the most popular because it was the oldest and got bundled with all the servers. So you would have a server and then one of your endpoints would serve this API documentation for free because of the way it was configured. And you've got Swagger CodeGen, which is the thing that takes, a definition file, a YAML file, and it generates it can either generate static documentation or the SDKs, the clients, the mock tests, all of that stuff, because it's a templating system. And there's validators on your definition file. So you want to make sure your definition file is valid, little things like that. There's several bunches. Those are Swagger today. And OpenAPI simply refers to the specification, how to write YAML files.
So Swagger is the tooling and OpenAPI is a specification. That's a distinction.
Correct. More specifically, Swagger is a finite set of tooling. A lot of tools now are, becoming OpenAPI tooling in order to adopt the more open name, if you will. So Swagger is a very specific set of tooling, most of which is still curated by the company that took on Swagger, and that's SmartBear.
When you say curated, you mean these are open source tools?
Correct. The vast majority are all open source, and they either live in GitHub and they've got communities around them.
I understand.
I keep looking at this and I'm thinking, okay, well, people can use this to kind of automate the process of using the APIs. And now we're talking about some of the tools. Are there tools out there that test APIs or do pen testing on the APIs or things like that based on the OpenAPI?
We are seeing tools spring up like that I want to say all the time, but the more niche ones come and go. A lot of companies have in-house tooling that do their own form of pen testing, if you will. Testing APIs is quite tricky. You can certainly do input-output tests, sort of as, if I give these inputs, I expect these outputs. And validation is a form of testing where you can put this during your runtime so that requests coming in will go through this validation layer to make sure that, it matches the type that OpenAPI has already described. But actual testing of saying, yeah, my API is up and all the operations in it work as expected, that's a little harder because there's a lot of semantics involved with that. But there's definitely more and more interesting use cases coming out of OpenAPI that we're seeing. Right now, the big one is around oversight, making sure your APIs look and feel the way you want them to, especially when you have hundreds, sometimes thousands.
Can you give a more detailed example of what you mean by oversight?
So oversight, where for me are those two things of breaking changes, right? So diffing between APIs and making sure your description of your API is consistent. Whether that's you've got every object has a 400 or every response has a 200 request. So in order to ensure this, you have these systems in place that look at the YAML files and do linting on them. So that's oversight for your CI/CD pipeline. So you can now see how consistent your APIs are.
This episode is sponsored by Cloud66. I have a Rails application and I was looking for a flexible product that takes care of deployment and gives full control of my application so I can focus on developing my code. I came across Cloud66 for Rails, which deploys your Rails application onto any cloud or server. At first, I thought it's like Capistrano, but then I realized it's way more than just deployment and gets you to scale servers, replicate and backup databases, protect your servers with firewalls, and much more. It acts as your in-house DevOps team to build, deploy, and maintain your Rails applications. It's really developer-friendly, and no wonder that companies like Baremetrics, Glossy's, Career Builder, Discovery Channel, and many development agencies and I are using Cloud66. You can try Cloud 66 Rails for free and get $100 free credits with the code RubyRogues-19. That's RubyRogues-19 at cloud66.com. Yeah, that's one thing that I like, right, is that, as we get into programming languages, we get used to sort of the overall schema of the way things are put together. And so, yeah, it kind of has a consistent feel. And if something doesn't match the flow of the language, it kind of sticks out whenever we have to use it. And so, yeah, I like that as kind of an audit of your API to go, okay, I'm looking at the entire spectrum that we have here, and that one doesn't fit, right? And so then I can go in and I can say, yeah, we need to fix that. So, the parameter names don't line up, or the parameter names indicate one type over another, or, the naming just, we've got RESTful all over here, and then we've got this weird outlier for whatever reason. How can we make it line up?
Exactly. It could be as simple as, I don't want to see a URL that includes the word execute on it, right? Because that indicates some sort of RPC thing that sort of breaks our RESTful ideology. And consistency gives you a lot of freedom, right? If you know that without researching this 1 out of 100 APIs, that it's going to behave and look and feel the way you expect, that gives you a leg up in consuming that API.
Yeah.
Can you do like a little bit maybe of a name dropping? I mean, can you give examples of like APIs or services that our listeners might be familiar with that you can name that currently already use OpenAPI?
Sure. So the OpenAPI team itself is like all the big boys are in it, from Google through Amazon. Microsoft has got 2 guys on it. Google's definitely in it. Amazon uses it for all of their OpenAPI or API gateway stuff. They've got, so here's another use case. That's a great way. Amazon, if you've ever worked with their API gateway, you've got to describe the sort of runtime thing that your requests come in, and then either you tend to link those to Lambda functions. So Lambda functions are these tiny little programs that you can put in the cloud, if you will. And so Amazon has the system. In order to make some of those connections, you can use vendor extensions on your OpenAPI YAML. The YAML file you describes the HTTP part. Great. But what if you wanted to add some custom stuff in there to say, well, this operation, this one should be linked to that Lambda function, or this operation has, these constraints on it, and I should flag every time this operation is called, I want this red flag to pop up in my system. Now you can go in there and you can add this to the YAML file where your API is described. So these consuming services can now know more information about operations and your API in general. Amazon's gateway is a great example of this, or AWS's gateway. Microsoft is a big proponent of OData. It's another format or more constraints on the way your data is formed. OpenAPI it really was the collection of these disparate entities who wanted to formalize it. There are different HTTP-based schemas out there, and they wanted to get the standard, right? That tends to be what OpenAPI is, the standard agreement on that.
Now, you wrote a whole book on this. We're sitting here and we're going, okay, kind of get bits and pieces of this, but what's kind of the flow of the book? How does it explain this, and how does it guide people through being able to use these techniques and tools?
Cool. So yeah, I'm writing a book. It's not complete yet, but the book I'm writing, Designing APIs with Swagger and OpenAPI, is a primer to give you value out of using OpenAPI, right? So we start with describing APIs today, because a lot of the HTTP APIs, they exist today, and it's a little bit of the Wild West of knowing what's in there. So the very first thing is, let's get it on paper. Let's put it down so we can use it. And then building on from there, we look at how we can design APIs without having written code first, right? What's the process around designing your hopefully RESTful APIs or HTTP-based APIs before you write the code? And what sort of feedback loop can you get out of it from, getting your server stubs up, getting a front-end engineer to start coding against that, and getting that feedback that can tie back into your YAML file that you use as the center of this little universe. And then lastly, in terms of the flow of the book, so part 1, let's describe the API. Part 2, let's design APIs. Part 3 takes a look at, well, how can I get some real juice out of the system? Something similar to what AWS's API gateway has, where they've added data into the operation. How can I look at building my own tooling around OpenAPI so I can get more mileage out of it, for my own purposes, things that haven't been built yet?
I think you're publishing it with Manning, so it'd be on the Manning Early Access program.
Yeah, you should definitely go check it out. It's, I think they call it MEEP, Manning Early Access. Yeah, that's the one.
I know. I always feel funny saying MEEP. Go
yeah,
MEEP.
it's true.
Go MEEP it, folks. MEEP away.
Exactly. So yeah, it's definitely out there, and part 1's done, and we're going through part 2 with part 3 pieces as well.
Yeah, I was looking through it before this podcast, and it looks really good. So congratulations on that.
Thank you. Appreciate it. One of my big driving factors here is first to give value out of it, because that's where any conversation starts, is, it needs to provide you with value. But secondly is to see how it can evolve. I'm a real big proponent of schemas for things. Once we've got a schema, once we've described something to some sort of formal spec, the world is our oyster. There's so much tooling that is yet to be designed around this. It's sort of another dimension on top of it. Once you can have an API, and once you can start putting an API in a box, which you've described it now, and you can start moving and interacting with that box, right? It becomes another dimension of operating on APIs as data. And that excites me a lot.
So if we said that OpenAPI is a schema on a schema, then your book is a schema on a schema on a schema.
Right? We need to get those little indexes up there. I like that a lot.
It's turtles all the way down, right?
Exactly.
Oh, very cool. So what aspects of this have we not asked about or talked about?
OpenAPI and Swagger, the disambiguation is still a thing. And I'm glad we get to chat about it, because OpenAPI, that's the spec is the heart of it at the end of the day. And it's important to encourage people to describe things. Maybe if it's not their APIs, it's something else. But putting things down on paper is an incredibly powerful thing. The tooling around OpenAPI today is very mature. We're seeing it grow. The OpenAPI specification itself is versioned. So we'd had a lot of people will see Swagger 2, which is now supposed to be called OpenAPI 2. And we're currently on OpenAPI 3, which brought in a huge amount of power to you as a writer of API definitions to be able to describe more and more things. And that specification is being worked on constantly. So the 3.1 release is going to bring in even more powerful features to it. So it's something to keep an eye on, especially as tooling catches up with those features. So yeah, version of the spec is important to know, because a lot of tools will support 2, perhaps not 3. But the maturity of 2 is like years and years old. Maturity of 3 is about, I want to say, a year and a half old. But the tooling is definitely fast on this, thanks to all that effort and open source of getting the stuff up and going.
Makes sense. I'm also curious about some of this. It seems like we're kind of in this season where a lot of things are evolving with APIs. We've got REST, and then we've got GraphQL, and then we've got gRPC, and we've got, I'm trying to remember, there were a couple of other ones that looked really, really interesting. One of them started with a V that was, anyway.
Well, there is one there I'll stop you on, which is quite interesting. It's hypermedia. So hypermedia is the purists for REST, right? So
yeah,
guys,
we
you really want to do
that
REST
for years on Ruby Rogues.
So that's definitely getting some traction as well, getting hypermedia, and how that ties into HTTP, how it really leverages the full power of HTTP. Just to complete the list, which was...
Yeah. I guess what I'm driving toward is, where's all of this taking us, right? We get better tooling, we get better ways of specifying APIs, and then, maybe we get better APIs. Do we wind up going to a place where this actually impacts, maybe there's a hypermedia API or, something like that comes out of this, where it's like, look,
right,
this methodology makes it really easy to specify in this way, and it makes all of these tools just kind of seamless, right? Where I don't even need the Twitter driver anymore. I just need an OpenAPI driver.
Right.
Are there other directions where this is heading?
So I think the direction is to treat APIs as first-class citizens by turning them into data. And the idea being, once we've got them in data, we can operate on them just like any other form of data. And that's sort of the direction we're going with here, where we've got schemas and we're describing things, different cases of them. gRPC, what it did was it brought something called protobufs, right, which are fantastical compact binary format that is great for speedy protocols, right, where HTTP is quite large and it's still text-based. And it took that and it added a schema to it. And by that very merit alone, it's taken gRPC into so many more applications because now you know how to use it. Now you can know how to use it by being able to share it, by being able to critique it just by looking at the schema. Once you can treat APIs as first-class citizens, as data, you get to look at the whole world as a different way. And just showing how that, gRPC, which took protobufs, great protocol, and just added a schema on top of it. And that's the power behind it, getting in front of into people's systems by leveraging that, which I don't think would have been possible without having a schema. gRPC's power comes from being able to generate your servers and clients, so that you can talk this protocol buffer, which is very hard. It's, very compact, very binary. So you want to automate that. And that's from treating the API itself as a first-class citizen. So that's the direction I think all of these things are working their way towards. That's
really, really interesting. And it's always interesting too, just to see, for all the things that you're talking about that you see coming, some of the unintended things that are going to come out of this that are going to make a difference for people too.
Right. That's the exciting part, the stuff that we haven't, thought about yet as a result of these innovations around the world and APIs and other things too. If you think about the APIs, do we want more of them or do we want less of them? Once you weigh that question, you think, well, APIs are good. They allow me to build things that I couldn't build before. Right now, because of all the APIs that exist out there, I can send SMSs, I can make phone calls, I can spin up images in the cloud at a whim. And so, yes, we want more APIs. So anything that helps us get more APIs, I think is a good thing. It allows us to innovate on whole new levels.
So do you know when the book's going to come out?
I think it's coming out next year, mid next year, I think. I'm not actually sure on the end date. I'm just writing at heavy pace because it's interesting stuff. And I'm sure my publishers will shout at me to narrow it down and give more concrete things like that. But I think it's planned for mid next year.
Sounds great. I'll see if I can find a link to it on the Manning Early Access. And hopefully people can get their hands on it because I think that would be awesome. Is there anything else, Dan, that you feel like we need to talk about?
No, I think it's pretty well covered from my perspective.
All right. As a Ruby developer, you've probably used Redis for queuing and caching. But if you're like me, you've never completely understood it. You just followed the tutorial to set it up and then hoped it'd stay up. Now that I'm building my own services for other people, I realize that you and I often don't have the desire or time to run an ops or DevOps team or do it yourself. Plus, since you're not a Redis expert, you're not exactly sure how to know what it's doing. That's why I love RediScreen. No setup. It runs on any AWS region I want, so I can run it near me. And the tooling is amazing. I have to tell you about this feature, actually. It actually maps the memory you're using and tells you where all the memory is allocated. So this makes it really easy to see what's going on in your Redis setup. It also runs on AWS, so it scales easily and can alert you when it hits certain thresholds in performance or capacity. Sorry for going all fanboy on you, but I love this tool. Here's the thing. If you don't want to do ops or are already on Heroku or something, then use RediScreen for the rest. It's simple, yet powerful. Check them out at rediscreen.net. Well, then, should we go ahead and do some picks?
Yeah, let's go for it.
All right. I usually let our hosts go first, but my wife is going to walk in here literally in like 2 minutes. And she's going to be like, okay, it's time to go. My 3-year-old has a Halloween program for her preschool class. So,
oh, that's so nice.
Yeah, we're definitely doing that. We're recording this on Halloween. So happy Halloween, everybody.
Night.
Yeah. None of us are wearing any sort of a mask.
There is a mask on my hoodie. It's a Ruby Rogues hoodie. And there's a mask on our logo. In fact, I should just throw this out there. So if you go to teespring.com/stores/devchat.tv, if you go to the show notes, you can get it. And I'll probably also have some link like shirts.devchat.tv or something that you can hit. But yeah, I'm putting up shirts for the different podcasts. People can, go and buy shirts. I get asked about this periodically. Where do I get stuff? I'm like, well,
I want stuff, Chuck. I want stuff.
Yeah. So I'm just going to put that out there. Last time we ran campaigns for this, which was a few years ago, I bought this hoodie And so the one I'm wearing as we record this is the one that's up there for sale. Well, not the exact one, I guess, but same design, same, manufacturer and stuff. We also have women's tees. So if that's something that you're looking for, we're going to put that up too. I've had a few people ask me about Patreon and things like that as far as being able to support the show. So I'm working on getting that up. So yeah, I'm going to throw that out. Another quick pick that I have, and this is something that I've used for a while. I just don't pick a lot of the tools that I use because I don't think about it. It's kind of become an everyday thing. But one of them is BusyCal on my Mac. Really loving that. It's a terrific program. Makes the calendar thing really, really easy. I think I've added like 20 something calendars to it because I'm insane and because we used to have a calendar for every show. That's part of the deal. We don't anymore. Now we just manage it on like 2 or 3 Google calendars. So I'm going to pick that because that's been really great. Anyway, I'm going to go ahead and drop off the call and I'll let Dan and Josh do their picks and then we will have another show next week. So max out, everybody.
Enjoy. Have fun with your daughter.
Will do.
Okay, Josh, do you want to pick your picks?
So you'll have to help me out here, Dan. What are we picking? What's the field of?
It could be any sort of pick you like. It doesn't have to be to do anything with software. Actually, my picks have nothing to do with software. If you want, I will go first and I'll give you a few more minutes to think about yours. So I've been running over the last couple of episodes through all sorts of what I consider to be really, really good fantasy books from authors that have kind of dropped off most people's radar. So they're less known. Given, everybody's still familiar with Tolkien and obviously with Game of Thrones and George Martin and all these sorts of books. So I'm running through a list of less well-known books, which I still consider to be incredibly awesome. So this time I'm going to mention a series of books called Saga of the Pliocene Exile. It's by Julian May. She's an awesome author. She wrote these way back in the 80s. It's a series of 4 books. It's not exactly fantasy. The wrapping is actually more like science fiction. It's people like living in the future where it's a very advanced society. We've encountered aliens and the humans are part of this galactic type federation. And some people don't fit in because they're outcasts and just can't handle this modern existence. So when there's this sort of a doorway that's open into 6 million years in the past on Earth, and it's just this one-way doorway. So once you go back, there's no return. So you go there and then you have to stay there. And the people don't really know what's back there except that it's prehistoric Earth. So a lot of these sort of people decide to go back there, and what they find there is really, really surprising. I don't want to spoil anything, but it kind of becomes a fantasy sort of a story once the people go back there. And it's not really magic, but it's like telepathy taking a form of magic. And, I'm not describing it as well as I would like, but it's a really incredibly awesome series of books. And I really, really highly recommend them. And yeah, so that's going to be my pick for today. And I'm going to put in the link to the Wikipedia post describing these series of books. And now over to you, Josh, if you have your picks.
Cool, Dan. Well, I don't think I can top that. That sounds amazing. And as a reader, I need to ask a big question. Is the series complete?
Yes,
I know that.
The series itself is complete. Like I said, it was written back in the 80s. She later wrote a whole bunch of additional books about different periods, like I said, because the beginning of the story actually happens in the future before they go back to the past. So she then kept on writing more books about the future era, and I've not read all of them, so I don't know if that's complete. But the books that describe that what occurring 6 million years ago in the Pliocene era, that's actually, like I said, those 4 books, and it's wholly self-contained, and the story is done. So it's not what would happen in a lot of series of books today where you start reading, you get all excited, and then you realize that the story is not come out yet and maybe never will. Hint, hint, George R.R. Martin. And no, so in this case, it's done, it's self-contained, and you'll totally enjoy it just reading those 4 books. You don't need to read any of our other books.
Thanks, Dan. That's important for me as a reader. Reading a series and getting stuck on a book and waiting for that next one is just so disappointing. And kudos to the authors who go into the effort of writing these stories that are so entertaining. But wow, I feel like I need to take on series completely at a time. All right, so picks. So while you were chatting, I had to think about things that I use quite regularly, and I'm going to list 2 picks. The first one is I discovered as part of writing this book. It's called ASCII Doc. And for those who don't know it, it's like Markdown, but kind of on steroids. And it's really cool to generate PDF files if you're comfortable writing Markdown files. So I would definitely go check that out. And my second pick is going to be a little command line tool, and it's called FASD. And I'm a console junkie, and I often love bouncing around on my terminal, but one of the stickiest points is navigating from one folder to the next. So this little FASD tool I use to jump to folders, usually using just part of their name. So long as they're in my ZHS or bash history, it'll make an educated guess and it'll get me there. So I definitely, if you enjoy messing around the terminal, this is a godsend.
Yeah, it sounds really awesome, and I'll definitely check it out. I use the terminal a lot, and I wasn't familiar with this tool, so thank you very much for that. Okay, in that case, I think I'll wrap it up. Wrapping it up for the first time by myself without Chuck. So thank you all for listening to JavaScript Jabber, and over and out. Bye-bye.
Happy Halloween.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CacheFly.com to learn more.